So we already know about the concept of EMF. EMF means it is an electromotive force. So where electromotive force, which means it is not a force, it is the potential difference between the two terminals when it is in an open circuit. So this EMF is generated according to Faraday's law. EMF is generated because whenever the change in magnetic flux is linked with the coil. We were keeping the coil as a stationary and we were moving the magnet, which means that magnetic field is changing, is linking with that coil, so that we were getting the we were getting the EMF. So this was the case while we were discussing the Faraday's law. So here what we are trying to do is, we can also create a EMF, we can also induce EMF by keeping the magnetic field as a constant. So it is a kind of a different topic to be discussed here. One more time telling you, in Faraday's law, we were changing the magnetic field, which will be linking with the coil. We are changing the magnetic field. But here we are not changing the magnetic field. Still, a EMF will be generated in the coil. Then how this works? Let's see. So in order to explain this, we need to take a rectangular coil. Before this, there is a cross of fields. Magnetic field lines are going into this plane. This is the magnetic field, direction magnetic fields, which is going into this plane, and that is a uniform time independent magnetic field. It is uniform and time independent. Time independent means which is not varying with the time, which means that the magnetic field is a constant at all the time. So this is the uniform time independent magnetic field. Now let us place a rectangular conductor. We are placing a rectangular conductor. Now we are placing a rectangular conductor. You can shade this. Let me name this as P2RS, P, Q, R, yes. This is the P2RS side. Okay. The length of this side is L, and length of this length of this side is X. Length of this side is X. Now, so this is a rectangular conductor we have taken, and this rectangular conductor is placed in the uniform magnetic field. Observe it here, magnetic field is not at all changing here. Still we induce a EMF. Then let's see how does this happen. Okay, see here, this rectangular conductor, that is a P2R. Here, the rod P2 is a movable, and all other sides, that is RQ, RS and S, this three sides are constant. It is not able to move, but the rod PQ is movable on this rod. Okay. So as soon as you move this rod, you will observe a change in area. As you move towards this, you have to move this rod towards this direction with the velocity, with the speed v. With the speed v, you are moving rod P2 towards this. So as soon as you move, the area occupied by this will be very less. Area will change. Initially it was some other area. When you move to some distance from this position, again you will observe or notice there is a change in area. So that is why here, whenever the rod peak is moved, we can observe the change in area. Okay. And the friction generated due to the movement of rod along this conductor is negligible. I am telling you, I am repeating this. Whenever you are moving the PQ on this, there will be friction and it is negligible. Okay. Now what you have to do? You have to find out whether EMF will be generated. Yeah. Now see. So the rod PQ is moving. So if the rod is moving, then the magnetic flux linked with this coil. Here the rod is moving. Magnetic flux linked with that. Magnetic flux linked with coil PQRS is, how to find magnetic flux? That is phi B, B into A. Let's say theta is 0, BA cos theta. So if theta is equal to 0, theta is angle between area and magnetic field. They are along the same line, that is why it will be 0, B into A. A means area of this rectangular coil. So area is, how to write the area? Length, we know the length and breadth, x into, sorry, this is x. Sorry, I mistake. I have to write here L. L is a breadth, length is x. So I can write phi B is equal to B into x into L, which means it is an area. Now this is a magnetic flux linked with that coil. Then what is the force acting on this? That we need to find out there. That is also we can do. Yeah. Now if you know this, let it be. Now we have written that the phi B is equal to B into x into L. That is a magnetic flux linked with that coil. Then what is the induced EMF there? Induced EMF in the PQRS is, how to write induced EMF according to Faraday's law? E is equal to minus d phi b divided by dt, and which is equal to minus of d by dt of phi b is equal to b into x into L, b dot x into L. So here b is a constant and L is also constant, but x is a variable. So that take the b and L outside, BL minus of dx by d. X is remain there, dx by d. So this dx by dt can be written as a speed minus dx by dt. That is why we can write BL. So this is the equation for EMF induced in a rectangular coil placed in a uniform magnetic field. See here. Now we got the equation for EMF induced in this coil. And the case was here magnetic field was kept constant and the coil was moving so that the area was changing. So that is why the EMF can be generated not only changing the magnetic field but also changing the area. So this also happens. So that is why this EMF generated due to the motion of this rod, that is why it is known as motional EMF. So this is the concept of motional EMF, and this is very important in the perspective of your exam. Will be asked for functions.